Moving on with 8.5, it says state whether the graph is a function or not and give the domain and range in interval form. Okay. Well, first we can test whether this is a function or not by doing the vertical line test that we learned in problem number 1, and hopefully you can easily see that this would fail the vertical line test, so somewhere we'll have to note that this is not a function. Okay, not a function, because it fails the vertical line test. Then next it says to find the domain and the range, okay, in interval form. And the way this works is that the domain are the x values of the function, and the range are the y values of the function or the relation. So when we look for the domain, what I think about is what is the furthest left spot that this picture reaches, and what is the furthest right spot that this picture reaches. Okay, so what we have then for the domain is we have the left spot, which is -1, and the right spot, which is 5, and we separate those with a comma. Now if it hits, which this does, it comes and touches -1, we want to use this notation of a bracket to signify that it does touch -1. And the same thing is it touches 5, and so we'll use that bracket for interval notation. So the domain is -1, 5. Then looking at the range, I think of the low spot. Okay, here's the low spot on y, which is 1, 2, 3, and then the top spot here, which is at 9. So what I'll do now is I'll use that same idea that it does touch 3, comma, it does touch 9, and that will give me the range for the function. Okay. Looking at the next one, it does pass the vertical line test, so it is a function. Yes, a function. And then for the domain, it's a little strange. If you think about this, this would go left forever, and it would go right forever. Okay, not thinking about up and down right now, just left and right. Well, one way to write that is to write -infinity, comma, infinity, and then we want to put this softer parenthesis notation next to the value of infinity, because you can't reach that spot. Okay, and then likewise, you know, it goes up and down forever, so the same thing can be said. We write -infinity, infinity. Okay, and you might see a radio button that says all reals, meaning all real numbers. Okay, so looking at the next two, first ask yourself, does it pass the vertical line test? Yes, it is a function. Next, think about the domain. We're thinking left. This is left forever. And then right forever. So we could say all reals, or we could use that fancier interval notation that's -infinity to infinity. And then the range, when we think about the low spot, remember for the range we're thinking about low to high. So let's see, the low spot, well, this goes low or down forever, and this goes down forever, so it doesn't have a low spot, so we'll put -infinity. But it does have a high spot right here. That's actually the high spot of this graph, and then it comes back down. So this high spot right here is actually a 0, and it does touch 0, so I'm going to use that stronger bracket notation there. Okay? Now this one's maybe a little hard to see, but this is a vertical line. And if you drew a vertical line through a vertical line, it would hit it everywhere. So this is not a function. And I wanted to put this one in your notes because it's a little tricky for the domain. If you notice the domain, its left spot and right spot are the same. The left spot and the right spot are at -7. So we have two ways that we could state that. We could state x equals -7, or we could say, using this brace here, -7. Okay? Your choice there. And then for the range, it goes low forever and high forever. So we can write all reals, or the fancier interval notation of infinity to infinity. Okay? Make sure you use the proper end notation if it does touch it, and we won't have the stronger notation next to the infinity sign. Alright, I hope that helps with finding the domain and the range.